What's up, YouTube? It's me again, Arwin Nathaniel Ramento Alfonso at your service, wherein we're going to discuss the self-exercise that occurred in our previous lecture video. Okay, but first and foremost, let's make a recap of what we have discussed. So, we discussed the outline, the symmetry in nature, the existence of symmetry in nature, the importance of molecular symmetry in chemistry, the symmetry operations, of course, and each of the symmetry operations that can occur for us to determine the molecular symmetry or point group of a molecule. Okay. Now, for our first practice exercise, ayan, we also discussed the concept of principal rotation, principal axis, the highest value of n. In our self-study exercise, we can see, let me read number 1. Among the following molecule, why does only xenon tetrafluoride contain a four-fold principal rotation axis among the 4 molecules? So we have CF4, okay, CF4 here, CF4, SF4, boron tetrafluoride, and XCF4. Kapag kasi ito-drawing natin guys yung carbon tetrafluoride, the SF4, the carbon tetrafluoride is tetrahedral. Okay, tetrahedral yan. And SF4 is seesaw shape. Seesaw shape. This is also tetrahedral. This one is square planar. If we visualize the molecule of a tetrahedral molecule natin, for example, for boron trifluoride and carbon tetrafluoride, ganito yung tsura niya, right? So, wala siyang principal axis na fourfold. Kapag kasi sinabi natin fourfold principal axis, is ano yung formula ulit natin, di ba? N is equals to 360 degree all over the bond angle. Since it is equals to 4, the bond angle is, that is 90 degrees. Ganito. So, in the case of our tetrahedral, wala naman siyang 90 degrees bond angle between here, but rather it only contains a 120 degree. Same case with also the seesaw shape na SF4 natin, sulfur tetrafluoride. So, ang principal axis niya actually ay C2. And for our XCF4, xenon tetrafluoride, we can see that it is 90 degree. So, that is the reason why xenon tetrafluoride is the only one contains a fourfold principal axis, because the tetrahedral one contains C3, this one is C2, and this one is also C3, and this one also contains C4. Okay? That's it. Ano lang, kadali yun. Now, for our number 2 problem, as it states here that draw the structure of XEF5. Now, in here, we can see that there's an extension to the BSEPR theory na kung saan the existence of a xenon pentafluoride exists. Itong tawag sa structure ay pentagonal bipyramidal. This is its structure, wherein meron daw siyang C5 axis. When it contains a C5 axis, ayan, 360 degree over C5 or 5, ang degrees niya ay ilan? 72 degrees between the angle here. So, the C5 axis na mapapansin niyo dito, syempre hindi ko din drawing yung hindi dito because hindi na kaya nung clay. Ayan. The C5 axis occur, of course, at the top. Dito, ang C5 axis niya. The C2 axis ng ating xenon pentafluoride ay nandito to all of its terminal atoms or the bonded molecules. Kasi when you flip it, all of them, ayon, mare-retain niya yung kanyang original configuration, di ba? So, it is symmetrical. So, if, to answer the question for this, is the marked C5 axis ay nandito. C5 axis are here. The C2 axis ay nandito sa lahat ng mga terminal atoms niya. Ayan, to answer our question. And right? Ayun, C5, C2 axis. That's it. Huwag natin pa-komplikaduhin kasi madali lang naman yung magiging tanong dito. Ang mira pa lang is the determination of the point group. Ayan, so I wrote this, the C5, ayan, C5, C2, and so forth. Next natin is, of course, we also discussed the plane of symmetry, sigma V, sigma H, and sigma D. Sadahan lang natin yan because we discussed this on the previous lecture video. Let's go immediately at the self-study exercises. Sabi dito that dinitrogen tetraoxide is planar. Show that it possesses a three planes of symmetry. Okay. So if we going to construct that, ganito magiging itsura niya. So we have nitrogen molecule, right? Nitrogen molecule here. So we have this one. This one's nitrogen. And ang planar yun kasi depends. It says that this one here into is planar. So oxygen natin. And then ayan. Cis oxygen for that. Ayan. And ito structure ng N2O4 natin. So actually kulang ito kasi N2O4. Kunwari ito na lang yung ating I ran out of clay for that. Okay, what if this? Ayan. The structure ng N2O4 natin. Ayan, it is planar. Yeah, it is planar of course. This one. Ngayon, nasan daw yung mga ano natin dito? Yung mga planes natin, plane of symmetry. Diba? So, ganito representation niya for you to visualize. So, if we're gonna draw this on a paper, ganito ang itsura ng ating N2O4 via Volin stick model. Planar naman yan eh. Ayan. So, ang question na tinatanong dito is nasan yung ating mga planes. So, meron tayong planes dito. Diba? It is symmetric. I say that. Ayan. I just draw this. Ayan. And for that, when we draw it, so, ang representation niya ay dito. Hati niya ay dito sa may gilid natin. Gilid. So, we have data plane of symmetry. Meron din tayong plane of symmetry here, dito sa gitna, and dito sa gitna dito. If we are going to draw that on a paper, this one is here, and this one. So, those are the three plane of symmetry sa ating N2O4. Okay. So, that's it. That's for number 1. What about number 2? Number 2. So, boron, tetrabromide, has the following staggered structure. Pero according to this, ito daw has one less plane of symmetry than B2F4, which is planar. So, i-drawing natin yung planar structure niya, ating B2F4. It is also similar to our N2O4, diba? And based from our discussion earlier, this one contains 3 plane of symmetry. So, ano yung nawalang symmetry dun sa ating staggered diboron tetrabromide? So, we have here, ayan, plane of symmetry dito, and also on its plane dito, sa gitna, right? So, ang nawala dito, guys, na plane of symmetry natin is yung nandito. Why? Because this one is not identical to its other side, di ba? It's not identical. So, ayun, that's the answer. Kasi, ito, reflection nito, ganyan din dapat. And then, the reflection of the other is dito, pag ganun lang din. So, that's the one thing. Yung ating vertical. Okay? For our, okay, Ga2H6 has the following structure na gas phase. Show that it possesses 3 plane of symmetry. Ito, it's very simple. The plane of symmetry, the one are here, vertical. Also have a horizontal. Yan, di ba? And yun nandito sa gitna natin, the molecules. Yung pinakita ko kanina, ayan. Yung pag ganito. Dito, the other side here. Galit. Dito. Ayan. We can see that. Okay? So, next natin. So, we answered that. Next, we also talk about the inversion center. Okay? Inversion center. Improper rotation and self-study exercises natin. Okay. So, paano kaya? Explain why boron trifluoride has an S3 axis but NF3 does not. It's just simple. Okay. So, we have a trigonal planar structure. Yung principal axis natin ay let's have a 3D molecular model for that. So, ito. Ang principal axis ng ating boron trifluoride naman is dito, di ba? Dito. And ang working definition ng ating improper rotation is magkakaroon tayo ng plane dito na it's a scratch. Ayan. So, it has a plane here and then magkakaroon tayo ng tusok dito. Ayan. Rotation followed by reflection. And it's the same molecule, di ba? Kasi dito naman tayo tumusok dito sa may plane natin, sa may pa-vertical. And wala naman mag-change. Ayun. But however, remember that this one does not contain an inversion center. Ha? It does contain axis of rotation. Okay? In the case of ammonia, ang ammonia acid natin is like this. So, ayan. Ammonia ay na-trigonal planar. Hindi siya, na-trigonal pyramidal. Hindi siya planar. So, ang principal axis natin ay dito. Pero, wala naman tayong plane dito, di ba? Wala tayong plane here. Di ba? It will not yield a similar structure because it's not planar. So, that explains why does the boron trifluoride contains an S3 rotation while the NF3 does not. Okay? So, it's simple as that. Huwag nating pakomplikaduhin, okay? For number 2 is the C2H6, the ethane, possesses an S6 axis. Show that the axis lies along the CC bond. Okay. If we draw this, okay, staggered conformation. Actually, meron sa internet. I'm just going to paste this one. Okay. So, staggered conformation of ethane natin ay okay. This is the top view of it. Wait lang. Top view. Wait lang. I'm just gonna show in the whiteboard perhaps. Wait lang guys Bear with me. Medyo, ayan. And the side view of this staggered ethane is this. Ayan. Can you see it? Okay, yes. So, the ethane, ayan, makikita natin, it contains, we have here, ilang degrees to? You think? 60 degrees. So, di ba? 60 degrees, 360, and substitute, kunin natin is 6. That's why it's called S6. Kasi ito, when, for example, in this principal axis, pagka nagkaroon na rotation tayo dito, followed by reflection, it will yield the same molecule. For example, ito, for example, na-rotate natin. I'm just gonna show you on PowerPoint presentation. Ayan. So, where am I? Ayan. So, for that, ayan, drawing natin. We have H here. We have H here. And plane dito. We also have here. And then H dito. H dito. Ayan. So, nagkaroon na tayo ng C3 rotation. We will have a C. After C3 rotation, ganito naging itsura niya. Ayan. So, you need to use your imagination further. Kasi talagang gamit na gamit siya. Ayan. So, after some rotation, dito, ayan, di ba? Then, i-reflection mo. So, after some reflection, it will retain to its original position or value. Kasi, pagka tayo nagkaroon reflection, kunwari, susulat ko ulit siya, it's the same molecule on the first, di ba? Ayan. So, that is why this one contains an S6 rotation or possesses an S6 axis dun sa ating molecules natin on staggered ethane. So, that explains it. Why? Okay? So, I hope you get it. Remember, this is quite a complex topic and it requires a vast imagination. Okay. So, let's proceed to the other. Yan. So, this one are the another operation. So, how many planes of symmetry do of the following possesses? The symmetry elements for ammonia, symmetry elements lost from going ammonia to NH2CO4, and the mirror planes that have in common for these four. So, in this case, this is slide number 19. Pipaste ko siya sa whiteboard natin. Okay, just wait a second. Just gonna face this on a whiteboard. Just having some trouble. Yan. So, let's go to whiteboard. Ayan. So, sa symmetry planes natin, guys, is we need to draw the structure of these three. Okay? So, the BSC pair theory for this, for A, ayan, C, and then F and F. Ayan, I hope you are seeing this one. So, how many planes of symmetry? Dito sa gitna. And dito. So, how many? 2. What about the letter B? So, nagbagi substituents natin. C double bond O, Cl, and F. Ano ang plane of symmetry natin? Dito lang sa molecule, dun sa gitna. Wala dito kasi they're not symmetric. They contains different bonded atoms. So, this one is 1. For letter C, so H. Okay, ayan. So, this one's H. So, how many? Ganun din. Dalawa lang din. The plane of symmetry are here. Ayan, dito. And dito sa gitna. Here. So, it's is equals to 2. Get it? Do you follow? I hope you are following, guys. Remember, plane of symmetry dito sa may gitna and then dito. It must be always, remember, identical to its original configuration. A fun reflection. Okay? So, let's go at the number 2. Okay, number 2 tayo. So, yung ammonia daw natin. Okay, ammonia, what are the symmetry elements daw for our ammonia? Let's draw. Wala ko sa internet ng representation ng ammonia natin for us to visualize further the molecule. Okay. Ammonia. Ang ammonia natin in structure ay ganito. Ayan. Ganito structure ng ammonia natin. Structure of our ammonia. Ayan. So remember, it is not a planar, di ba? Hindi siya planar, guys. It is trigonal by pyramidal. Okay, trigonal by pyramidal siya. So, hanapin daw natin. So, symmetry elements E, of course, identity. Meron naman na yon. Structure of ammonia, letter A is such as this. Ayan. So, we have plane here. And then this one. Ayan. What is the meaning of E operator? So, just the molecule itself, okay? Okay. So, walang mababago. There's no alteration. So, draw the diagram to show the symmetry elements for the ammonia. So, this one here, dito sa top view natin, ito ay C3. Why? Because the bond angle between here is 120 degree. Dito. So, dito, in the top view, ito ay C3. Ayan. The C2, dito, no. Sorry for that. Does not contain a C2. but rather it is a sigma V. Sigma V. Sigma V here. Dito rin. May sigma V rin tayo dito. Plane of symmetry. And also we have a sigma V here. Ayan. So, that's it for our ammonia. Ngayon, ang mangyayari daw dito, guys, is what if yung ammonia natin is nagkaroon ng yung isang hydrogen niya ay substitute ng another substituents such as the NHCl. So, from this, siya ay magiging ganito. H and this one Cl and then H. Ano yung nawala sa ating ammonia, the symmetry elements? Dito, meron ba tayong C3 here? Meron tayong C3 dito? Wala. Kasi they are not identical eh. Parang ganito yan. Let me show you how this. So, this is our ammonia. Papalitan mo ng panibagong molecule such as chlorine. Saba blue. Ayan, ganito. So, kapag ba nirotate mo ito ng 120 degree, same pa rin ba siya? Is it indistinguishable from its previous configuration? Di ba nagbabago na? Kasi yung blue na dating nandito, napunta sa top. Therefore, it's not. The lost are, ang nawala yung C3 natin. Dito. Nawala yung C3. So, nawala yung C3. And then another, nawala ng dalawang sigma V. Bakit? Kasi, ito lang yung magiging sigma V natin. Hindi naman pwede dito. Kasi we have a different atoms here. So, to answer the question, what are lost are isang C3 and dalawang sigma V symmetry elements for that ammonia. Okay? So, for number 4, okay, let's go at the number 4. Boron trifluoride and CF2, F2C double bond O have the following symmetry elements in common. E2 mirror planes and 1 C2. So, i-show down natin. Okay. First, let's draw the molecule. So, this is the BF3. Diba? They are both 120 degrees. Also, it's C double bond O. Kung mapapansin ninyo, sila ay para sa trigonal planar. Remember, paano ko ba nalaman na ganyan structure niyan? Kasi malakas ang foundation ko sa BSEPR theory and I also had a background in organic chemistry. Kaya alam ko ito rin mga structure na yan. So, I hope you have one too. But I'm just going to explain this. So, syempre, identity, automatic, it is a character, symmetry element of every molecule. Two mirror planes. Saan daw yung mirror planes natin? Mirror planes natin. Dito, guys. Ay, ito. Mirror planes 1. Mirror planes 2. Ayan. Also, same here. The mirror plane 1 and mirror plane 2. Tapos, meron daw silang isang C2 na principal axis. Saan yun? Dito sa molecule natin. Nandito ang C2. Sorry for that. A terrible drawing. Nandito ang C2 natin. Sir, ba't walang C2 dito? Kasi magkaiba yung substituents nila eh. Diba? Dito sa may boron trifluoride natin, meron C2 dito, meron C2 dito, meron C2 dyan. However, what is stated in the question are show down naman, diba? So, those are the similarities of these two molecules given. Okay? So, let's go back at the PowerPoint presentation. So, okay. Ayan. So, we also discuss and point groups of the molecule. Ayan. So, for the point group determination, perhaps I'm going to discuss this in the next lecture video kasi medyo mahaba na ang lecture video natin for this. So, this will be continued on the part 3 for us to take a rest for a little bit. Ayun. So, because I discussed only the symmetry elements. Ngayon, dito na. Point group determination na tayo. on the next lecture video. Thanks so much, guys. Hope you learned something. See you on our next lecture video.